Imagine driving on a perfectly smooth highway at high speed. It feels effortless, almost ordinary, yet beneath your tires lies one of the greatest engineering achievements of the modern world. Every road you travel has a hidden story that begins long before the first layer of asphalt is laid. It starts deep inside mountains, where enormous machines and carefully planned explosions transform solid rock into the foundation of the highways that connect cities, countries, and millions of lives. Today, we're following that incredible journey from raw earth to the finished road beneath your wheels. Most people never stop to think about what a modern road is actually made of. It isn't simply a layer of black asphalt spread across the ground. It's a carefully engineered structure built from multiple layers of crushed stone, gravel, sand, bitumen, and advanced construction materials, each designed to perform a specific job. Every layer must support enormous loads, drain water efficiently, resist temperature changes, and withstand decades of constant traffic. If even one layer fails, cracks begin to appear, potholes develop, and the road slowly starts to break apart. The scale of this process is almost impossible to imagine. A single kilometer of modern four-lane highway can require tens of thousands of tons of crushed stone, thousands of tons of asphalt mixture, hundreds of truckloads of material, and weeks of non-stop work by skilled crews and massive construction machines. Every section of road represents a carefully coordinated operation involving miners, engineers, surveyors, laboratory technicians, equipment operators, and logistics teams working together with incredible precision. Everything begins at enormous open-pit quarries, where engineers search for strong, durable rock capable of surviving decades of punishment from heavy traffic and harsh weather. These quarries stretch across entire mountainsides, exposing layers of granite, limestone, or basalt that have taken millions of years to form. Before a single stone can be removed, specialists carefully study the geology, mapping the strongest sections and planning every stage of excavation. Once the site is ready, giant drilling rigs bore deep holes into the rock face, often reaching depths of 20 meters or more. These holes are filled with carefully measured explosive charges connected by electronic detonators programmed to fire with millisecond precision. When everything is finally in place, workers move to a safe distance, the countdown begins, and within seconds the mountain erupts in a controlled explosion. Thousands of tons of solid rock break free, filling the air with thunder, dust, and powerful shockwaves that echo across the landscape. The freshly blasted rock is then loaded by enormous hydraulic excavators into gigantic haul trucks capable of carrying hundreds of tons in a single trip. These machines look almost unbelievable in size, with tires taller than an average person and engines producing thousands of horsepower. Their job is simple but essential: transport the raw rock from the blasting area to the crushing plant as efficiently as possible. At the crushing plant, the transformation truly begins. Massive jaw crushers powered by powerful electric motors squeeze giant boulders between heavy steel plates, breaking them into smaller pieces with incredible force. The sound is deafening as steel meets stone, while thick clouds of dust rise into the air despite sophisticated dust control systems. Secondary and tertiary crushers continue reducing the material until every stone reaches the precise size required for road construction. The crushed stone then moves onto a network of vibrating screens that separate every particle according to size. Fine sand falls through the smallest openings while larger pieces continue to additional crushers for further processing. Every fraction has a purpose, from tiny mineral filler to larger aggregates that provide strength and stability. Engineers know that even a few oversized stones can reduce pavement performance, so precision at this stage is absolutely critical. But crushed stone alone cannot create a modern highway. The secret ingredient is bitumen, a thick black binder produced during the refining of crude oil. At normal temperatures it is almost solid, but when heated to around 160 degrees Celsius it becomes a sticky liquid capable of coating every piece of aggregate. This remarkable material acts like industrial glue, locking millions of individual stones together into one durable pavement capable of supporting enormous loads. Transporting these materials to the asphalt plant becomes a carefully timed operation. Fleets of heavy dump trucks continuously deliver crushed aggregate from nearby quarries while insulated tanker trucks transport hot bitumen from refineries, keeping it at the correct temperature throughout the journey. Every delivery follows a strict schedule because delays can interrupt production and cost thousands of dollars every hour. When the materials arrive at the asphalt plant, another remarkable process begins. Towering steel structures, conveyor belts, storage silos, and mixing equipment work together like a giant automated factory. The first step is drying the aggregate. Fresh stone often contains moisture that would prevent proper bonding with bitumen, so it enters a massive rotating drum heated by powerful burners. Temperatures inside the drum reach between 150 and 180 degrees Celsius, while the drum slowly rotates, lifting and tumbling the stone through intense heat until every trace of moisture disappears. From there, the hot aggregate passes through precision vibrating screens and enters separate heated storage bins according to particle size. Computer-controlled weighing systems measure each ingredient with extraordinary accuracy before releasing them into the mixer. Engineers understand that even the smallest variation in material proportions can affect the strength, flexibility, and long-term durability of the finished pavement. Finally, the heated aggregate drops into the mixing chamber where hot liquid bitumen is sprayed evenly across every stone. Powerful mixing shafts rotate continuously, coating millions of particles in less than a minute. Steam rises into the air, the smell of hot asphalt fills the plant, and another perfectly blended batch is produced. Every load is sampled and tested before leaving the facility, ensuring it meets strict quality requirements for temperature, density, and material consistency. Now the race against time begins. Fresh asphalt starts cooling the moment it leaves the mixer, so it is immediately loaded into insulated dump trucks designed to maintain its temperature during transport. Construction crews coordinate every movement because the material must arrive at the paving site while it is still hot enough to be compacted correctly. Every minute counts, and every delay reduces the quality of the finished road. At the construction site, the dump truck carefully transfers its load into the hopper of a modern asphalt paver. Instead of simply dumping the material onto the ground, the truck and paver move together in perfect synchronization. Inside the paver, conveyors carry the asphalt toward rotating augers that distribute it evenly across the full width of the lane. Behind them, the screed smooths the hot mixture into a perfectly even layer with remarkable precision. Although the road already looks complete, it is still far too soft to support traffic. Heavy steel rollers immediately follow the paver while the asphalt remains at the correct temperature. Their enormous weight, combined with powerful vibrations, removes tiny air pockets trapped inside the mixture and compresses it into a dense, durable surface. Pass after pass, the rollers create the smooth pavement that millions of drivers will eventually travel across without ever realizing the extraordinary engineering hidden beneath their tires. By the time the sun sets, what was once a rough construction site has become the beginning of a brand new highway. Yet this is only part of the story. Before a single vehicle is allowed onto the road, engineers must prove that every layer meets some of the toughest quality standards in modern construction. Behind the scenes, advanced technology, artificial intelligence, precision testing, and human expertise are about to reveal whether this road is truly ready to serve the world for decades to come. Modern road construction has entered a new era where digital technology works alongside human skill to achieve levels of precision that once seemed impossible. Long before construction begins, engineers create a complete three-dimensional digital model of the highway, mapping every curve, slope, bridge, drainage system, and elevation with centimeter-level accuracy. Every machine on the project follows this digital blueprint, transforming a virtual design into a real roadway with remarkable precision. Today, many construction machines know exactly where they are at every moment. Using advanced GNSS and RTK GPS technology, bulldozers, graders, and asphalt pavers constantly compare their position to the digital design. Hydraulic control systems automatically adjust blade heights and paving depths several times every second, ensuring the finished surface remains almost perfectly level. This technology reduces waste, improves efficiency, saves fuel, and delivers smoother roads than ever before. The asphalt paver itself has become an intelligent machine. Modern sensors continuously monitor material temperature, paving width, layer thickness, screed position, and material flow. Onboard computers instantly analyze thousands of data points and automatically make adjustments whenever conditions begin to change. Infrared sensors watch the temperature of the fresh asphalt while laser guidance systems maintain precise alignment. The result is a road surface that feels almost perfectly smooth beneath the tires of every vehicle that passes over it. After each section of pavement is completed, another wave of technology takes over. High-speed laser scanners inspect the road surface, searching for tiny imperfections that are almost invisible to the human eye. At the same time, autonomous drones fly above the construction site, capturing thousands of high-resolution images from every angle. Powerful software compares these images with the original engineering design, detecting even the smallest differences long before they become serious problems. Behind the construction site, a sophisticated control room operates like the brain of the entire project. Engineers monitor live information from every machine, tracking fuel consumption, equipment performance, material temperatures, weather forecasts, production rates, and construction progress in real time. Artificial intelligence continuously analyzes this data, warning engineers of potential problems before they can affect the finished road. What once required hours of manual inspection now happens almost instantly through intelligent monitoring systems. But despite all this advanced technology, the final decision still depends on rigorous quality control. Fresh asphalt samples arrive at specialized laboratories where technicians begin a series of demanding tests. They carefully measure binder content, aggregate grading, air voids, density, moisture levels, and temperature using highly calibrated equipment. Every sample must meet strict engineering specifications because even a small variation could reduce the lifespan of the highway. One of the most surprising quality checks involves drilling directly into a brand new road. Using powerful diamond-tipped core drills, engineers remove perfectly cylindrical samples from the finished pavement. These cores reveal every construction layer, allowing technicians to verify thickness, density, and compaction throughout the structure. Although it may seem strange to cut holes into a newly completed highway, this process ensures that hidden defects are discovered before the road opens to traffic. The testing continues inside advanced laboratories where hydraulic machines apply enormous loads to asphalt samples, simulating years of heavy truck traffic within just a few hours. Climate chambers expose the pavement to freezing winters, scorching summers, heavy rainfall, and repeated temperature changes. Engineers carefully observe how the material responds to stress, measuring cracks, deformation, flexibility, and long-term durability. Only the strongest mixtures earn approval for real-world use. Perhaps the most remarkable part of the entire process is that experienced engineers still play an essential role. Even with artificial intelligence, laser scanners, drones, and automated sensors, veteran inspectors can often detect subtle warning signs simply by walking across the finished pavement. Years of experience allow them to notice tiny texture changes, unusual sounds beneath their footsteps, or slight variations in surface appearance that computers may overlook. Technology provides incredible accuracy, but human judgment continues to make the final difference. Once every laboratory test has been completed and every inspection has been approved, the highway is finally ready to open. Drivers see only a smooth black surface stretching toward the horizon, rarely realizing the extraordinary journey hidden beneath their wheels. Every kilometer represents years of planning, thousands of engineering decisions, millions of tons of carefully selected materials, and the combined efforts of countless skilled professionals working together. The importance of roads becomes even more impressive when viewed on a global scale. Today, the world is connected by more than 64 million kilometers of roads, linking cities, farms, factories, ports, and communities across every continent. These transportation networks support global trade, emergency services, education, tourism, and daily life for billions of people. Without modern roads, the movement of food, medicine, raw materials, and essential goods would slow dramatically, affecting nearly every aspect of modern civilization. Road construction has become one of the largest industries on Earth, generating hundreds of billions of dollars in annual investment. Countries continue expanding and upgrading transportation networks to support growing populations and stronger economies. Nations such as China, the United States, India, Japan, and Germany have developed some of the world's most advanced highway systems, introducing innovations that influence road construction projects across the globe. The industry has changed dramatically over the past 50 years. Surveyors who once relied on measuring tapes now use satellites. Paper drawings have been replaced by intelligent three-dimensional digital models. Heavy equipment that once depended entirely on operator skill now works with automated guidance systems capable of achieving astonishing accuracy. Construction has become faster, safer, and more efficient, yet the dedication and expertise of skilled workers remain just as important as ever. The future of road building looks even more exciting. Researchers are developing self-healing asphalt capable of repairing tiny cracks before they grow into major damage. Engineers are increasing the use of recycled asphalt, reclaimed concrete, recycled plastics, and recycled rubber tires, creating more sustainable roads while reducing environmental impact. Smart highways equipped with sensors may soon communicate directly with connected vehicles, improving traffic flow, increasing safety, and supporting the next generation of autonomous transportation. Some experimental highways are already exploring wireless charging technology that could recharge electric vehicles while they drive. Other research projects focus on solar-powered road surfaces, intelligent traffic monitoring systems, and advanced materials capable of lasting significantly longer than traditional pavement. These innovations could completely transform the way future generations build and use transportation infrastructure. The next time you drive along a smooth highway, remember that it didn't simply appear overnight. It began as solid rock hidden beneath the Earth's surface. It passed through powerful explosions, giant crushers, towering asphalt plants, intelligent construction equipment, advanced laboratories, and some of the strictest quality inspections in modern engineering. Every layer beneath your vehicle represents thousands of hours of planning, precision, innovation, and human determination. The next time you travel on one of these roads, take a moment to appreciate the invisible world beneath your wheels. It was born from the earth, shaped by heat, engineered with extraordinary precision, perfected through advanced technology, and approved by some of the highest construction standards in the world. What appears to be an ordinary highway is, in reality, one of humanity's greatest engineering achievements, a masterpiece of science, innovation, and teamwork that quietly connects the modern world every single day.